All right, geometry. This is your last segment of Unit 2. 2-5, three-dimensional figures. All right, this one's full of just standard formulas. So we're going to have a couple examples, and we have a slew of formulas we use. But we have a vocabulary word, polyhedron. A polyhedron is a closed three-dimensional figure made up of flat polygonal regions named by the shape of their base. Okay? So we have some basic standard ones. We have our prism, the right regular pyramid, which has a square base, the cylinder, the right cone, meaning the height and the radius make a right angle, and the sphere. Now, let me show you a couple things that will make the assignment a little later easier. Okay. First off, please note, everything is in reference of R. R is the radius. And that is from center to the edge. Okay, center to the edge. Center to the edge. Center to the edge. But what you're given sometimes is diameter. The diameter is from edge to edge. Now, if you are given the diameter from edge to edge, to get the radius, take that diameter and split it in half. Okay? Because you want R, not D. Okay? You don't want your diameter. When you do these equations, you want your radius. Another thing I showed, particularly with these volumes, okay? I want to show you something. All right. I'm going to do it with the volume of the sphere. All right. So your equation is 4/3 pi r cubed. Now check it out. This is 4/3 times pi times r cubed. So if you multiply 4 pi r cubed, multiply all of that together, and the very last step, divide by 3. Okay? Same thing with the volume of the cone. Pi r squared h, do that first, and then divide by 3. Okay? That'll help you out. Make your life easier. I also want to point out, on your calculator, you have a pi button right here. So when you're calculating these equations, use your pi button instead of 3.14, because 3.14 is the mathematical what we use, but when you have a pi button, it'll get you a slightly more accurate answer. Okay, so use your pi button. Make sure you round to whatever it tells you to. We're going to be rounding to the nearest 10th. Okay? So we have our formulas for surface area and volume for all of our standard shapes. So S is total surface area. P is the perimeter of the base. Okay, a base is a flat surface. Radius we've gone over. Volume. Okay, so surface area is like if you were taking wrapping paper and wrapping it around the shape. Volume is if you were pouring water into the shape. B is area of the base. big B. Okay? And then H is height of a solid, and L is slant height. So you get a slant height, okay? You got a slant height when you get a point. So like the pyramid or the cone, okay? L is your slant height. All right, so let's see what we got. It wants us to find the measure of a three-dimensional figure. We got cone. Okay. Find the surface area and volume of the cone. All right, easy enough. We got cone. We got a couple formulas. Let's do this. Well, in order to find surface area, you need your slant height. This is a right cone, so that means the radius and the height, they form a right angle. So our radius and our height form a right angle. So the radius, the height, and the slant form a right triangle. So we are missing the L currently. Okay? And in your right triangle, you have sides A and B, make up the legs, okay, of the right angle. And then your hypotenuse, or C, is the slant. So we have our equation. A squared plus B squared equals C squared. That's your Pythagorean theorem. And that's a standard equation for a right triangle, so we can find our missing side. Okay? So we do not know what C is. A is 8. B is 15. Alright. So that equals 64 plus 225. C squared equals 289. We don't want C squared, we want C. So we're going to take the square root of, okay, both sides, and C equals 17. All right, so now we know that our slant height is 17. Okay. Now let's find the surface area. What if we wanted to wrap wrapping paper around this cone for some reason? So we have pi. Again, we're going to use our button. We have r, which is our radius, which is 15. And then we have L, which is 17. And we'll need height for volume, which is 8. So let's find our surface area. Pi times r, which is 15, times L, which is 17, plus, well, not h, plus pi, sorry, r squared. All right, 15 squared. So our surface area is pi, and we got 15 times 17. Oops. 15 times 17. 255. Plus pi. And that's 225. All right. S equals, so 255 times pi, 801.106. I don't round till the very end, so let me see, it wants us to round to the nearest tenth. I don't round to the nearest tenth till the very end with my answer. Plus pi times 225, 706.858. Alright, S equals 801.106 plus 706.858. So 1,507.964. And we have to round to the nearest tenth. Okay. So 1,508, because that is my 10th spot. Alright. So that is my approximate surface area. Now the volume. So let me change colors so they don't all run together. Volume equals 1/3 pi r. My r is 15. 15 squared. H is 8. Alright. Volume equals 1/3 pi times 225 times 8. So 225 times, oh, that was by typing the right number, 225 times pi times 8. Pi 225, 8, okay. Then we're going to, lastly, divide by 3. So our volume equals 1884.95. Alright, round to the nearest tenth. So my volume is approximately 1,885 inches cubed. Alright. Yep, this is also in inches. Alright, so we have got, is that inches cubed? No, it's inches. I'll have to look that up. So we have our approximate answers. My brain is not braining right now. Alright, so we have done our cone. Now let's do a real world example. So on the back, we're going to talk about the pyramid at the top of the Washington Monument. And if you've ever been to the Washington Monument, it's kind of cool. And I actually did something wrong in class when I calculated it. No one called me on it. So, cool. But I'll fix it here in the video. Alright. So we have our Washington Monument, okay? And it measures approximately, okay, we have a square base, and each side is approximately 34.5. Okay, that's my side. 34.5. Alright, each side. Okay. It's a square base. So the volume of the pyramid is approximately this much. Okay, cool. What is my height? So I'm looking for H. Okay. Now let's go back on the front. And I have a volume of a regular pyramid. My equation is 1/3 B, which is big B, H. Alright. Now B on the front tells me it's the area. Equals the area of the base. Now in order to get the area of the square, big B equals 34.5 squared. So it's 34.5 times 34.5, because we want the area of that whole base, not just one side. That's what I got wrong in class. It happens. Alright. So let's see. 34.5 squared. You have a squaring butt right here, x squared, equals. So big B equals 1,190.25. Alright. So that's my big B right there. All right, so my volume is 1/3 BH. So I have B, I have V, it told me, is this, 21,821.25. All right, so I have the big B and I have V. I'm looking for H. Now, when I have these formulas, it is wise to rearrange the formula before you put your numbers in, because you are much less likely to make a mathematical error if you rearrange your formula. So we're going to rearrange our formula in terms of H, okay? We're going to get H. We're going to get everything else on the other side, and we're going to get H on this side. So right now, H is multiplied by B, so let's divide both sides by B. Then that gives you 1/3 H equals V divided by B. All right, these are multiplied, so we'll multiply by the reciprocal to isolate my H. And that gives me 3 times the volume divided by big B. All right. Now, because H is what I was looking for, I was looking for height. Okay, now I have my formula rearranged. Now I can plug in what I know. Okay, so I'm going to 3 times my volume, 21821.25. Divide that by my big B, which is the area of the base. That was the error I made earlier in class, 1190.25. And that's going to give me my height. All right, let's figure that out. So I have got 3 times the volume, 21821.25. I typed it in right. Cool, cool. And then we're going to divide that by 1190.25. 55. Okay. H equals 55 feet. That actually makes more sense now. All right. And I did have someone question me what B was, but they didn't quite sure understand why it was wrong. But we knew it was, yeah, cool. That makes more sense. All right, so the height of this triangle is 55 feet, not over 1,000 feet. Yes. All right, so anyway, there is an assignment. Use some of those strategies and some of the little hints I told you in the notes, because that will help you. All right. Good luck.